IP addressing. That's what we're looking at. So we're going to look at Internet Protocol, which is what IP stands for. I'm going to switch over to my slides so that we can get started. Okay, there's a question. Hello, Mr. Francis. Hello, Mr. Francis, can you hear me? Mr. Francis seems to be off now. Hello, Mr. Francis, can you hear me? I'm not even sure the microphone on his own end works. But if you can hear what I'm saying, let's get started. Okay, so today we're looking at the Internet Protocol. Before we get started, before we jump right into Internet Protocol, Mr. Francis says he cannot hear me. Can you please refresh your browser? Okay, so before we jump right into it, I need to explain something about IP address. Now, IP address is something that we term connectionless. Like IP address, yes, it identifies the system on the network, but it does not help you transfer packets from place to place. It's actually baseless. There's no way it helps you in the communication. It's just like a stamp, a rubber stamp on a system. That's why most of the time when you talk about a complete connection, you hear them mention TCP/IP. So TCP is the one that controls the packets, how it arrives at the destination, how it leaves the source. IP just helps it identifying the systems. So that said, let's move on straight to our class today. And we're talking about the Internet Protocol, IP address. It's a unique address that identifies a device on the internet or local network. In summary, it identifies a device on the network. It doesn't matter what type of network. And then it serves two main functions. Either it helps you identify the host or network interface, or the location addressing. Those are the two main functions of IP addressing. If I'm to expatiate on that, this is what it will be. Identifies the host, or more specifically, its network interface, of course, because it is not the computer itself that has those addresses. It's the network interface. That network interface, like, you remember we talked about NIC in the last class. So that network interface that is attached to the card that is attached to the computer, that's what the IP address is attached to actually. So identifies the host, or more specifically its network interface, and it provides the location of the host in the network. Okay, so it helps you establish a path to the host. Now let me break it down into these characteristics. A name indicates what we are looking for, the address indicates where it is, and the route indicates how it will get there. This is what is packed up inside an IP packet or an IP address. Okay, I hope you can hear me. I hope so. Mr. Francis, I hope you can hear me now. Moving forward, there are two versions of your IP address. Two used versions, because before version 4 came up, there was other versions earlier that wasn't up to code. So version 4 and then version 6. Normally you hear people say IPv, IPv4, IPv6. The V is version. Now that's what we're going to be looking at. Now one of them, that's the IP version 4, is more common because it's more understandable. IPv6 is a bit more complicated, but I will get to the point where I'll explain why they have to move from IPv4 to IPv6. Okay, IPv4 was being exhausted. That was what led to a new coming together, or a new product by IETF. That's the Internet Service Provider. That's the Internet Engineering Task Force. They're the ones that came up with the concept of, okay, since this is about to finish, let's come up with something new. So towards the 1990s, around the 1990s, IPv4 was running out. So a new protocol has to come up, which was termed IPv6. So let's start with IPv4 and look at the IPv4 addressing. From there, we'll talk about the public and private IPv4 addresses and do a simple implementation of the IPv4 address. Okay, so moving forward, let's talk about IPv4 address. It's a 32-bit number that uniquely identifies a network interface on a machine. The picture you see there, that's how an IPv4 address is written. Dotted decimal. Now, the 32-bit is divided into 4 8-bits. 4 times 8 is 32. So each section divided by the dot, or separated by the dot, is 8 bits. Okay, and that's what your IPv4 address on a simple platform looks like. There are times when we convert this to binary, to zeros and ones, but for now, this is with the knowledge of this, you are okay. So what you're looking at now is an IP address where there's already a distinct difference, or a distinct identification of what the network part of the IP address is and what the host part of the address is. So the network part specifies the unique number that is assigned to the network. Okay, it's like, let me give you an example of a street. You see the number 1, let's use Adeni Jones. Adeni Jones is the street name. So the numbers, number 1, number 2, number 3 belongs to the houses. So the network part is like the street name. That belongs to everybody. Everybody share that same name. So the host part is the one that belongs to the computer alone. That's what we're referring to. And now how you can clearly understand which part belongs to the network and which part belongs to the host is when we talk about subnet mask. Okay? So let's just know this. Now each section, each part of this number, like the 129, 144, 50, 56, each part of those ones separated by the dot can go from 0 to 255. I hope we get that. It can go from 0 to 255. So you can have 255.255. Okay? Okay, now we understand that. Moving forward, the address space for IPv4. How many billion is this? This is 4 billion, right? And then how many billion did we say the IoT devices currently is hitting? If you still remember the answer, can you please say so on the live conversation? How many billion devices are we looking at currently on the IoT ecosystem? If you remember that, you know that there's a high disparity. In fact, there's a lot of difference between what you can accommodate using Internet Protocol version 4 and what IoT is requiring. Okay, someone said 7 billion. 7 billion is the population of the world. I'm referring to the population of the IoT devices, the devices that can connect to the internet. Can someone help or Isaac out with the correct answer? 500 billion. Is it 500 billion or 50 billion? Let's get our facts right. It's in around 50 billion. Okay, so think about it. If we only had 4 million addresses and 50 billion devices, you can imagine the difference. All right, so that was why the need for IPv6 had to be developed. There had to be a new development for a new protocol. So now let's look at what helps you differentiate the network and the host. That's what the subnet mask is for. Now you see the number under that says 255.255.255. That's what we're calling this. That's what the subnet mask is about. Now whenever it is turned on, 255, it is considered a network side. When it's not turned on, that's when it's turned off. That's the zero part of it. We identify that as the host. I'm just mentioning the default subnet mask. There are more confusions when it comes to subnet mask. There are more calculations. I'm just mentioning the default classful IP addressing. Would expatiate on all of this in the physical class, where everybody will have their pen and paper and will do the calculations and then do the implementations. But understand this simple thing. Well, whenever it says 255, 255, 255, all the ones that are attributed to the 255 belongs to the network, and the one attributed to the 0 belongs to the host. So in this address right now, only the 34 belongs to the host. The 192.168.1 belongs to the network. So in simple terms, if there are 10 computers in that network, all of them will have the same 192.168.1. The only difference in their IP address will be the last one, 33, 34, 35, and so on and so forth. Did we get that explanation? Okay, if we did, let's move forward. If we didn't, probably when we do the practical, you will understand a lot better. Okay, so this is what a simple address explanation or a simple address simulation will look like. I'm starting from this subnet 1, the IP address, this one on this side, the one that has an arrow. Okay, so you have IP address 192.168.2.182. Now, for a simple question, with this IP address, I hope everybody can see. Let me see if I can zoom in. Let me see if I can zoom into it. Okay, this simple IP address here, the one that says 192.168.2.182, which of the IP address, which of the numbers there belongs to the host alone? Can I get the answers on my live conversation or on the WhatsApp group? Let me know if you understand this. Okay, Joel Emmanuel said 181, 182, 182. Okay, so it means we understand what's happening here. Okay, Ajoke said network tripped off, but you're back now, right? Well, I've not gone very far. So I'm still going to reiterate on the things I said. I just asked a question about the IP address based on my explanation that whenever you see a 255 on the subnet mask, it means that that address belongs to the network. Now when it's turned off, you see a 0, that IP address belongs to the host. And then I asked a simple question: which of the address here, which of the numbers here belong to the host? Okay, so we got it correctly. 180, 181, and 182. Those addresses are the only thing that change, if you notice very well. Okay, so this is where it starts from. And then when we now have another network, do you notice the change in the network address? If you notice the change in the network address, can you identify it for me on our live conversation? What's the change in the network address between this first subnet and the second subnet? Are we there? I hope you can see what I'm projecting and you understand the question. I have two subnets now and different IP addresses, right? Yes, 201, 202, 200. And I'm saying, do you notice the change in the network address itself? Okay, Samuel said it. The 1 is the one that changed. So you have a 1 and a 2. Now, do you notice that, or let me bring to your knowledge that the subnet address or the network address that has a 1 and the network address that has a 2, they cannot easily communicate because there are two different subnets. Okay, the computer of 192.168.1.201 cannot easily communicate to the computer of 192.168.2.180 with that subnet mask that says 255.255.255.0. So a lot of all these things we're going to talk about it when we do in our physical class, when we do network, how to calculate subnets and the rest of them. But just understand this: the subnets are used to separate networks, to break networks into smaller pieces. Okay, now for communication to work between those two subnets, you have to introduce the default gateway. Do you get that right now? So the default gateway is the one that can now point one computer in a subnet to a different computer in a subnet, in another subnet. Okay, so the subnet is the gateway, is the one that's responsible for knowing which place to send your packet. Of course, default gateway is a router, so the router understands how to switch packets from one subnet to another. We get this, right? Now let's look at the public address and the private address. Now, before the solution for the IPv4 that was running down, that was finishing, before the solution was introduced as IPv6, a lot of research had gone into the works. Now, while that research was going on, there was need to maintain the IPv4 scheme but use it on the internet for as many users as needs be. So even though there was a 4 billion cap, they were looking for ways to continue using it without suffering the consequences of finishing it. And that's where the private and the public addressing came into play. Immediately the concept of network address translation was discovered, then the IPv4 scheme became a constant thing that would never be deprecated, that would never be left behind. And the concept of the public and private is this: if you are not connected to the internet, you don't have a use for a public IP address. If you're connected to the internet, you might, but you don't necessarily need to. So with the concept of network address translation, which is what some of the routers do by default, you sit in the private space and the router just uses one IP address, one public IP address, to direct you around the internet. Okay, so on the public side, you see it is required by devices and hosts that are connected directly to the internet. It must be globally unique. There must not be two of them in the world. It must be routable on the internet, and it must be assigned by the people governing the internet. On the private side, it is not routable on the internet because you only use it internally. Okay, it is not routable on the internet. It can be assigned locally by any organization. It means two organizations can be using the same IP scheme, but because it's not routable on the internet, nobody questions them about it. Okay, and that's for private. And it must be translated to access the internet. So whenever you want to use it to access the internet, you must use a translator, a network address translator, to translate it. The short abbreviations I mentioned just now, the IANA, the IANA, stands for Internet Assigned Numbers Authority. That's what that stands for. While the RIR stands for the Regional Internet Registry. Okay, so it doesn't look strange. So first of all, most of the things we do on networks, on the local networks, we use private addresses. And whenever we want to connect to the internet, the router does the task of translating the private into public address. Now let's look at configuring IPv4 manually and then automatically. Let me mention the one for automatically because that one happens without your knowledge. There's something called the Dynamic Host Configuration Protocol, DHCP. DHCP is the one responsible for sending IP address to hosts, to computers. Now that's what helps in the assignment of IP addresses automatically. Routers perform that function as well. Some computers can perform that function, Windows servers. So that's what handles the automatic part of it. Now there's a part of the automatic that's called APIPA. APIPA. APIPA is a technology that the computer himself or the computer itself assigns an IP address to itself. That means it chooses an IP address. The APIPA stands for Automatic Private IP Addressing. It automatically gives itself an IP address. That's automatic as well. I'll show you where all of this is done on the computer. Most of the other devices are automatically switched to automatic IP address. That means they receive it automatically, like your phones and the sensors, the devices. It's only computers and some high-level tabs that give you the idea or give you the capability to configure the IP address manually. So I'm going to show you how that is done. This is where we do it. This interface is where it is done. So I'm going to first of all share my own screen, share my entire screen, so that I can walk you through how we get to this place and then show you how we manipulate what is here before I can switch over to Packet Tracer and then we get the practicals done. First of all, I need to confirm that what I'm sharing is my entire screen and not just my PowerPoint slide. So I'm going to end the PowerPoint slide. Now I'm going to share my entire screen. Okay, good. Now let me immediately I switch from this screen, I will not be able to find out if you are seeing what I am seeing. So I'm going to rely on your conversation to tell me if you are actually seeing my own interface. Okay, so I'm going to go to a regular desktop. On my regular desktop, please chat me up on WhatsApp and tell me if you can see my desktop. If the live feed I shared, if you can actually see my desktop, please let me know. Okay, so my desktop is available, so I can go on. Okay, so first of all, I'm going to my network. I'm connected to a wireless network, but I'm going to go to my network and internet settings. Okay, now here on my network and internet settings, I want to manipulate my adapter options. Okay, this is Windows 10. Yes, other Windows will have it as network and sharing center. This will open this, so something like this is your network and sharing center. Let me bring it down so that people who don't have who are using mobile phones can see what we're seeing. Okay, so from here, everything here is Wi-Fi. If I click on this comes up. If I was using LAN, I'll be able to click on change the data settings as well. Okay, so here I'll go to properties of this Wi-Fi and it will show me the Wi-Fi properties. And on the Wi-Fi properties, you see Internet Protocol version 4 and Internet Protocol version 6. So let me click on Internet Protocol version 4 and go to Properties. So now you notice the current setting. The current setting says obtain an IP address automatically. It means that the router that is giving me internet is responsible for giving me an IP address. I hope we got that. And also DNS server is obtaining the DNS server address automatically as well. Okay, so the DNS is the one responsible for pushing you around the internet, for making you access the internet. The IP address only identifies the host, the computer itself. Okay, so I won't tamper with this, because immediately I tamper with it, I will lose network. That's one of the reasons why I'm using Packet Tracer. Okay, so I'm going to switch over to Packet Tracer. Okay, let me close this as well. Get back here, and then I want to share the Packet Tracer application itself. So I'll leave here and then share the Packet Tracer application. Okay, so this is Packet Tracer. It helps you simulate networks. Okay, it's a place where you can simulate your network. You can make mistakes here and not have issues, instead of buying devices just to learn how to connect them. You can simulate them here in Packet Tracer. A few of the things we're going to be using: if you are using a system, if you're working from a system, you can come along with me while I do this. Okay, so the first thing I'm going to do, if you look at the lower left corner, you would see some, you can see mine moving around. So here you will see devices. So this is where you pick the device category you want before you can select the particular device you want. I don't know if you understand that. It will be a bit difficult for the persons who are just watching and not following along, but I promise we'll still bring this up in the physical class so that everybody can be part of it. Okay, so I have end devices and network devices. So the first one I'm going to choose is end devices, and whenever you choose it here on the category, it shows you here. So all I need to do is click on PC and drag it and drop it here. Okay, I'm going to increase the size of the PC so that it will be visible for people to see. Relocate it here. This is for a personal computer, right? Now I'm going to bring a laptop as well and drop it here. Okay, so now I've been able to talk about end devices. I've been able to deal with end devices. Okay, so if you're walking around with me, if you're coming along with me, please do the same thing. Add one PC and one laptop, or add two PCs, as the case may be. Now let's move forward. Connecting the two PCs together. Remember, it is possible to connect from one computer to another. Okay, it is possible to connect from one computer to another, but in an ideal network, you connect to either a switch or a router. Okay, so because I'm connecting to a switch, I'm going to pick the network devices, and on the network devices, I'm interested in, if you pick the category on top, there are other categories under you can streamline it to. I'm talking about the lower left corner now of my screen. So I have network devices. The first one I clicked was end devices. Second one I click network devices, and under I have router switches. So I'm clicking on the switches and I'm picking the first switch, the 2960, and then I'll drop it here. Okay, that's not gotten the time where I'll show you the interfaces. So here, what's remaining for me now is to connect these three devices. So I'll go to my connection. The connection is the one that has this thing that looks like a thunderstorm. So I'll click on the connection. The thunderstorm itself is automatic. It helps you decide which cable you are supposed to use. But as time goes on, you should be able to understand which cable works for which. We already know that we have those 3 different cables: coaxial, fiber optics, and the twisted pair. Okay. Now, the twisted pair cables also have different types for different categories or for different kind of connections. There's one called the copper straight through. There's one called the copper crossover. The important thing there is not the copper, it's the straight through and the crossover. I'll explain when you need to use each and every one of these types of cable. Okay, so I'm going to move my connection. Okay, I'm going to use my cable to connect these devices. So in this case, I'm going to be connecting my PC to switch, and then from the switch to the PC, or the 2 PCs to the switch, as the case may be. Okay, I hope you understand all of this. Do you have any questions so far? Is there any question you want to ask? If there are questions, yes, I'll entertain the questions if I move forward so that I don't go too far. If there are no questions, we can easily continue. We can go ahead. Are we together? Can everybody hear me? Let me know I'm not talking to myself. Okay, okay, good. So what we're looking at now is connecting the PC to the switch. Okay, so the kind of cable responsible for this action is the copper straight through. So I would simply click on the cable, touch the PC, and choose one of the interface. In which case I'm choosing the fast Ethernet 0 interface. That's the Ethernet port, because I'm holding an Ethernet cable, so I'm connecting to the Ethernet port. So I'll click on the fast Ethernet 0 and drag it and go and drop it and choose one of the ports of the switch. In this case, I'll just pick the first one, the fast Ethernet 0/1. Got it, right? Now let me show you what the automatic does. If I've chosen the automatic kind of cable and clicked on the laptop and gone straight to click on the switch, you notice it didn't give me options. It automatically knows the type of cable. It chooses the interface by itself. Yes, it gets the correct interface, but I really would not advise, if you know what to do, please use the proper cable. I just did my Ctrl Z. So I'll use the copper straight through to connect the laptop, choose the interface myself, and get to the switch, choose the next available interface myself. Okay, now what we have done now, what we have been able to simulate now, is we brought a computer, a desktop, we brought a laptop, we bought a switch. Now we bought cables, connected the cable from the desktop to the switch and from the laptop to the switch. We haven't actually configured each of these guys. Okay, so to configure them, I'll click on the PC. I'm starting from the PC. I'll click on the PC. I'll go to configuration, and you see where it gives me access to enter what I want to enter. Okay, now if I don't want to do it from here, I'll click on the desktop tab, and here I can see the different things I can manipulate. I mean, it's simulating a real computer. So I can go to IP configuration, and you see it provides me with a similar interface to enter my IP address. If I clicked on this button that says DHCP, it means I want that PC to automatically pick up IP address for itself. But me, I want to be the one to enter it myself, so I click on this place and choose a very basic one, 192.168.0. Let's say 5. Now I don't need to type the subnet mask myself. If I press the tab key on the keyboard, it will automatically assign one. Now the reason why it's giving me 255 in 3 places is because IP addresses are ordinarily divided into classes: class A, class B, class C. And this is a class C address. When you see a 192.168, it's a class C address. It's the most popular IP address, the private IP address. So it means that 192.168.0 belongs to the network. It's only that 5 that is attached to the host. Okay, I'm done with this configuration. I can simply close this guy. Now let me test a scenario for you. Because I don't know the IP address of the laptop, there is no way I can actually communicate with the laptop to ask the laptop to ping it, to send you the message to say, are you there? Okay, so I'll have to go there and click again, go to either configuration or desktop, go to IP configuration, and then enter another one, 192.168.0.6. Press the tab key again and get that subnet mask, and then I can close this. If I hover around the first PC, it shows me the IP address. I hover around the laptop, it shows me the IP address. Okay, now the only thing is testing if the two can communicate. And one of the most popular ways you can test communication between two of them is the word ping. Okay, it's a command prompt language. So I'll go to the first PC and I'll open the command prompt. Okay, and then all I need to type is ping 192.168.0.6. I'll press the enter key. But do you notice that you get a reply? If you can see what is there, I know it's very tiny, but what is there is telling you reply from the IP address I pinged, and it's telling you it took a couple of seconds. It sent the entire 32 bytes, and then it took less than 1 second to reply. It means that both computers are communicating. If I do the same thing on the laptop, go to the laptop, go to command prompt and say ping 192.168.0.5, because that's what the other computer is, and press the enter key. It does that. Did we get this? Okay, Tonya said they are using a phone. Don't worry, I'm recording the session. I'm recording it, so when I upload, you can see what's happening. Probably when I upload it and send you the link, you can see the entire interface on a desktop. Okay, Ajoke said I should zoom and then start again from the beginning. Okay, let me see how I can achieve that. Okay. Okay, let me see. Now, because I'm only sharing the packet tracer screen, I think I'll share my entire screen. Okay, I'll share my entire screen so that it will be easy for you. So let me end this particular one that I'm sharing right now, and then share my entire screen. Okay, so I'll move over to the packet tracer. I know I should be able to zoom my entire computer while using the packet tracer. Okay, so what I'll do is I'll magnify. I'll get my magnifier. Wait for it to open. Okay, then my magnifier is here so that I can do this. Let me reduce the size again. It's only going from 100 to 200. Why is it not changing to like 150? Okay, let's manage this. So what I'll do is I'll repeat this configuration again. Okay, so let me delete the entire configuration. I'll click on delete. Because I'm magnifying, I can't do much. So let me delete this one. click on the delete button, then delete this one. One thing with this is only you click, select it. So let me delete this guy, then delete this one as well, and remove this one. So I hope we can see everything now. Let me get started from the beginning. First of all, I'll choose end devices, and on the end devices, the first one is for PCs, the other one is for home, smart home, and the rest of them. The reason why I had to bring packet tracer is because he understands IoT as well, so should be able to get things done. So I'll pick a PC and then drop it here. Then I'll pick a laptop and then drop it here. I can as well pick another laptop and then drop here, making it 3 now. Then I'll switch to network devices, and here I'll click on switches. So I'll pick a switch. I'm picking the first switch there, and I'll drop the switch here. Okay, so before the cable connection, since I already tested out I did the cable first before I assigned the IP address. Let me assign the IP address, test the ping before the cable. Okay, so I'll click on this PC. I'll come here and click on configuration or desktop. Then on the desktop, I'll click on IP configuration. So this comes up. Then all I need to do is type the 192.168.0. Let me use 200. Now all I need to do is press the tab key. I need to populate my subnet mask. Okay, I'm done with this one. There's no save, just close. Then I'll go and check. If you hover around, once you wait a little bit, it will display some information. It's because I'm magnifying, that's why it's not displaying anything. And then I'll go to the laptop one and then configure the laptop one, the same thing, desktop, IP configuration, and then do my 192.168.0.207 and press the tab key. This is done. And then I'll do the last one. I'll use this to test out a different subnet. I'll go to IP config and then I do 192.168.3.2. Press the tab key and then I'll close this. Okay, now let me deal with the connection between them. So I'll click on connection. I already know it is a straight through cable. If you hover around, you see the names of the cable. So a straight through cable to connect from the PC, which is fast Ethernet 0, to the switch. Then I'll choose the first interface on the switch. Let me shift this. Let me minimize and do something, then I'll come back and complete it. It already chosen one for itself. Okay, so I'll repeat that same thing again. I'll pick a straight through cable and connect this from fast Ethernet 0 to the switch. I can choose any of the interface. Okay, now I'm going to leave this one not connected. I hope you remember the IP address. It is .3, 192.168.3.2. So I'm going to test out the communication between PC3 and laptop 1. So I'll click on the PC. I'll go to command prompt and then I'll type ping, P-I-N-G, or give a space, 192.168.0.200 and what did I name the other IP address? Let me quickly check. This one I named this computer is .207. Okay, so .207. I'll press the enter key and then you can see the communication is complete. 4 packets sent, 4 packets received. Now the other one has an IP address of 192.168.3.2. Now look at what happens. is finding it difficult to send communication. It's timing out because it cannot find that address. It cannot get there. This is scenario 1. There is no cable connected. Now I'll test out. Let me connect a cable to the switch and then come back here and run it again. So I'll take a straight through cable and connect this switch. I'll use the next available interface and connect it to this laptop, to the next available interface. Okay, and then I'll come back. Remember, the first time we had 4 packets sent, 4 packets lost. I'll repeat the same procedure, 192.168.3.2. The same problem. Now, why are they having this problem? Why is he having this problem? He's having the problem because they are not on the same subnet. And what has determined this subnet is the subnet mask. Because we chose 255.255.255, the first 3 addresses must be the host. Only the last one that's meant for must be for the network. Only the last one that is meant for the host. Okay? I hope you understand this. Okay, so let me get off the magnifier. Sometimes it's annoying. Okay, so this is what you get. Now it's not only for connections, it's not only for IP addressing that brings me to packet tracer or to diagnosing networks. Sometimes you're browsing a site and you're having problems, like you're trying to log into this our portal and you notice that you're having some issues. It is advised that you troubleshoot some networking. You do some network troubleshooting. For example, the first thing that comes to your mind is it my internet? And the best way to test your internet is to go to YouTube and check if your internet can even load a video. If it can comfortably load a video and you're still having problems logging into the platform or reaching the platform, then there are some basic networking tips that you will do. I'll show you one of them. I'm used to coming to the command prompt. Let me still do the magnification so that we see what I'm trying to achieve right now. Magnify. Okay, so I'll come back to my command prompt. I want to ping the website itself. Now the website is lms.fmysd.com. So I'll send ping to lms.fmysd.com and check if I can even reach it. Now if I cannot reach it, it means there's a problem somewhere. Okay, this is one way to diagnose. And then not just diagnosing, there are certain times when your browser, your internet, your ISP keeps a local cache, a local copy of that website. Probably the website has changed something and you're still using the old version. It is advised you come and do this kind of diagnosing. A simple one would be ipconfig/flush DNS. This will totally remove everything that the DNS remembers for you to now start afresh to search for or to reach the website. All of these are simple things. If I want to see the IP address that my router has assigned to me, it will be ipconfig/all. It shows me every networking related thing on this system. So it shows me my host name. It shows me the media I'm connected to. If I scroll down, it shows me the IP address, both the IPv6 address and the IPv4 address. You can see mine is 192.168.169.23. That's how you can easily diagnose networking. This is simple troubleshooting. Okay, so far, do we have any question? Okay, I've zoomed out already. So far, do we have any question? There are questions, so we can tackle it right now. There are no questions. We'll just do a few things and then finish up for today. This is, I talked about assigning IP address automatically. I've mentioned this now. Troubleshooting tools, ipconfig, and ping. What we should have talked about now is understanding IPv6 address. Let's see if we have time for it to deal with IPv6. It's just an overview. IPv6 is a bit more complicated than IPv4. Okay, IPv6, instead of 32 bits that IPv4 uses, it has 128 bits on its own, but it has some benefits. Now, the benefit of IPv6 is larger address space. It can take trillions. It can handle trillions. Now, it has a hierarchical addressing and routing infrastructure. There's a hierarchy to it. You can tell when a company owns a particular address space. It's not just numbers. It's hexadecimal. It has alphabets and numbers as well. It has both stateless and stateful. You understand this more better when we do core networking on our physical class. Okay, just understand that IPv6 is a more improved version, but though it's more complicated to configure. Currently, nobody easily configures it in the Nigerian ecosystem, in the Nigerian space. The internet does not even use much of it. Yes, there are IPv6 internet space, but IPv4 is still up and doing. Now, the difference between IPv4 and IPv6, usually we'll have to come back here and check if there are questions. If there are not, I'll continue. Okay, so the difference, the IPv4 is performed by routers and sending hosts, while IPv6 is the host that's responsible for fragmentation. For address resolution, IPv4 would broadcast the protocol for request frame. Can you hear me? Can you still hear me? Hello, can you still hear me? If you can hear me, can you please say something on the live conversation? Everywhere is a little too quiet. Okay. So I was talking about the differences between IPv4 and IPv6, right? And I was mentioning how IPv4 handles the fragmentation and how IPv6 does that. Now, the record names, A record for IPv4 and quadruple A, 4 A's for IPv6. Are we together? Hello? Okay. The network was having some issues. So I was referring to IPv4 and IPv6, and I was mentioning that the DNS host records for IPv4 is A record, and for IPv6 is quadruple A. The minimum packet size for IPv4 is 576, and that for IPv6 is 1280. Now, these are the simple differences between IPv4 and IPv6. For address structure, you have what you're seeing right now on your screen. The loopback for IPv4 is 127.0.0.1. That for IPv6 is column 1. I will break this down for you better off when we have our physical class. But this is a typical step for DNS. This is a typical what you do on daily basis when you open your browser and type an address. So let's use a practical example. You open your browser and you type Microsoft.com. Now the computer you're typing the Microsoft.com for, what it does is to ask the local DNS server. The company that's responsible for giving you internet is the one that owns those servers. So the company that owns those servers is responsible for finding the root servers. Now the root servers are the ones responsible for, if you can see very well, it says Microsoft.com. Now the root servers exist after that .com. So the actual site you're going to is Microsoft.com dot. The root server is the dot. Now the root server understands where every address that ends with a com, org, anything is. So the root server goes looking for .com, because it's only that .com that would know where Microsoft is. The root server would not know. It only knows what is immediately by the left of it. So .com knows where Microsoft.com is, and Microsoft.com gets to the Microsoft.com DNS server, then finds out the IP address and sends the IP address of the Microsoft.com down to the local DNS server. And the local DNS server eventually sends the IP address to the client. Now, on the client system, either a phone or a laptop can now contact Microsoft.com directly just to retrieve that web page, Microsoft.com. Remember, there's an IP address attached to it. It is not actually Microsoft.com you're contacting, but their own IP address. I hope we get that. Okay, if we've gotten that, it means we are ready for our review. Remember, I mentioned that this week, today, our review is going to be longer. Oh, let's see. Network is very bad here. I hope the class will be recorded. Yes, I recorded the class. Okay, I do not understand at all. Okay, which part of it, Zainab? Which part of what I just said is confusing to you? Where did you stop? Where did you stop following me? Aliyu, where did you stop following? Hello, Aliyu. Mr. Muyudin, can you hear me? Hello? Can anybody else hear me? The simulation. Oh, okay, okay. It's okay. Oh, okay, sorry about that. Okay, Zainab said she got lost when I was trying to explain IPv4. Okay. All right, it's no problem. I would upload to YouTube and then forward our class to you. Then please attempt or attend to it today, because my assessment for today will be shut down by tomorrow morning. My weekend assessment, I would shut it down. I would stop receiving solutions or answers by tomorrow morning. Okay, so try and attempt the questions today, or watch the video when I finish uploading and send to you. Watch the video today, understand it. Don't worry about a deeper understanding beyond what I've explained, because we have decided that we are going to handle this again in the physical class. Okay, there's a lot of calculation involved that we cannot do virtually. Okay, so just if you can get the surface, if you can understand to the extent I've explained, if you can understand just the intention behind the simulation, then that's fine. Understand how to assign IP addresses. On my system, I went through how to get to those different places. For example, how to go to the network, how to go to network and sharing center, how to click on the properties of the network you're connected to, click on IPv4, and then assign the IP address. One of the reasons why I resorted to using a packet tracer is because of the fact that I cannot change my own laptop IP address while it's connected to a network. It will disconnect me from the class immediately. So I had to use somewhere to simulate it. Okay, in our physical class, I will make sure I come with a router and a switch so that we can practicalize it in the class. Okay, so you said something about assessment deadline. Yes, I'm uploading the videos immediately I stop the class now. I'm uploading the video and then I'll send the video. Don't worry, when I send the video to you, it wouldn't have audio problems. Okay, when I send the video, it won't have audio problems, so you can rewatch the video and then get anything you missed. That's okay, right? Okay, good. Thanks for today. I know the Friday Saturday class wasn't so comfortable for some people. We apologize for that. Next week we will be better at it. So if there are any questions, let's take some questions before we call it a day. If there are no questions, then we can move ahead to call it a day. But remember that today I talked about I started with IP addressing, and I looked at what an IP address is. I looked at the two different IP address versions, IPv4 and IPv6. I also went forward to talk about private and public address. Okay, and then from there I moved on to the network part of the IP address and the host part of the IP address. I mentioned how you can identify the network part from the host part by using what's called the subnet mask. I also went ahead to talk about the address space for IPv4, how it was about to finish, that led to IPv6. Okay, those are a few of the summaries of what we talked about. I looked at public and private addressing. I mentioned some things that are even not on my slides. Don't worry, I'm still going to send the slide across to you so that you can have the slide alongside the videos. Okay, it's a very short class. If not for the fact that we had some network issue before we started, we should have spent more time on the simulation. Okay, for those of you who are using systems who would like to continue the simulation, let me know. When you watch my videos and you cannot figure it out, let me know. I can give you some few tips, give some private classes on how to get across to doing that. Thank you very much for joining the class. If you have any questions, please do so. You can send that on WhatsApp as well. If you don't, you can call it a day. Okay, you said you want more emphasis on IPv6 and the command prompt. Don't worry about it. Like I said, we'll do a lot when we see physically, because I need you to be doing it while I'm doing it. I need you to follow along at the same time. I know it's difficult for you to you're open packet tracer, you're watching the live class, you're attending the live class, you're switching back to packet tracer to do something. It's a bit disturbing. Okay, so we'll tackle that issue. Although it's not directly connected to the IoT platform itself, but it's a prerequisite. I cannot think about you excelling in IoT without actually having the backbone of computer and networking. So we would definitely pay more attention to it at a later time. So thank you very much for joining the class today. We apologize for the initial network hitch, and we hope it will not repeat itself again. I would let me spend time and upload the videos and then send it across. Should in case I forget, please remind me. I'll send the videos across and then I'll send the assessment across. For those ones who did not have network issues, you can do your assessment immediately. The deadline for my assessment for you to submit my assessment is tomorrow. immediately to passes tomorrow, I would turn it off. Thank you so much for joining the class today. Have a nice weekend.